conceptual design and drawing of footings and retaining walls. In previous session, we have discussed about the IS 456 recommendations for designing of combined footing. Here, in this session, we are going to discuss about what are the design steps we are going to follow to design the combined footing. The first step would be the finding the area of the footing. In IS 456 recommendations, I already mentioned that the primary function of the footing is to transfer the loads from superstructure to the soil without undergoing the considerable amount of settlement and without failing the soil under the footing in shear. That is, whatever the pressure it is going to create on the soil should not be greater than safe bearing capacity of the soil. So, by considering this point, we are going to calculate the area of the footing. The first foremost step to find the area of the footing is to calculate the total loads that are coming from each column to the foundation. So, if you consider the combined footing is supporting two columns. So, one column is carrying 60 kilonewtons, the other column is carrying 90 kilonewtons. The total load is coming to the foundation from the column A in this scenario is 60 plus 90 would be 150 kilonewtons. Now, after calculating the total load from the superstructure to the foundation, then we have to assume what is the weight of the footing, because we did not we are not yet designed the foundation, but the weight of the after constructing the foundation, the weight of the footing also will be standing on the soil. So, in the first step of the design, we have to assume the weight of the footing, because we don't have the area of the footing. We don't know what is the area of steel we are going to do. So, to overcome this problem, we assume that the weight of the footing would be 10% of the load that are coming to the footing from the superstructures. So, in this scenario, total load from the superstructure is 150 kilonewtons. 10% in that would be 15 kilonewton is the weight of the footing. So, this is the weight of the footing. Then we calculate the total load on the soil. The total load on the soil would be the load from the superstructure and the weight of the footing. So, total 150 kilonewton plus 15 kilonewtons would be 165 kilonewtons. By knowing the total load, by knowing the soil bearing capacity, we are going to calculate the area of the footing using this formula. So, after calculating the area of the footing, we need to fix the dimensions of the footing. So, if the area of footing by this formula, if you get 15 meters square, you can take 3 meters as the width and 5 meters as the length of the footing. So, that is your wish. So, you have to fix the dimensions of the footing by using the area of the footing we have calculated from this formula. After calculating the area of the footing, we need to place the columns on the footings. So, the basic aim in designing the combined footing is the footing must experience the uniform pressure from the soil. So, to get the uniform pressure at the junction of soil and foundation, the CG of the footing must be coincide with the CG of the loads from the column. So, if you look at this diagram, this is a rectangular combined footing. You already know the CG of the rectangular would be at the center of the footing. Now, there are two columns which are going to rest on the footing, which is carrying, one column is carrying W1 weight and other column is carrying W2 weight. If the W1 equal to W2, definitely the CG will be acting at the midpoint of those columns. If the W1 and W2 is not equal to each other, we need to find the CG of these columns from any one of the column we have to calculate. So, you already know how you are going to calculate the CG of any particular thing. So, if you are calculating CG of two loads, that would be the load into distance of that load from the reference point plus the second load into the distance of that second load from the reference point by the sum of two loads. Here the loads are W1 and W2. The reference point is the first column. Definitely the distance between the reference point and the W1 will be 0. So W1 into 0 will be 0. Next, the W2 is the second load. The distance from the reference point, that is from the first column, will be L. So W2 into L by the sum of the loads will be W1 plus W2. So that is what I have written here. The CG, that is X2 bar, is W2 into W2L by W1 plus W2. So we have to now you know the CG of the loads from the first column. Now your work is to place these two columns on the foundation such a way that this CG1 and CG2 must coincide, so that we can get the uniform pressure distribution under the footing. So by fixing the position of the columns, then we are going to calculate the net upward pressure from the soil. So because every reaction has opposite reaction also. So the loads are coming from the superstructure. Definitely to overcome that one, soil will exert negative a pressure that is opposite in the opposite direction in the applied forces. So that we call it as a net upward pressure. Definitely the loads are acting in downward direction. The pressure from the soil will be acting in the upward direction. So to calculate the net upward pressure, we are going to use this formula. So total load on the column by area provided. So the units must be Newton per meter square. So this is the total load on the column, and the area provided is the area of the foundation. So after calculating net upward pressure from the soil, we have to calculate the pressure per unit length also. So the pressure per unit length would be net upward pressure into width of the foundation, width of the footing. Why we are going to calculate the pressure per unit length is, this is very important to check for one-way shear of the foundation. After calculating net upward pressure, now we have to calculate the shear force and bending moment which are going to experience by the foundation. So if you look at the diagram of if you look at this diagram, so this diagram will be look like as a overhanging beam which is subjected to UDL on it, and there are two supports. In this scenario, these two are the columns. So from the columns there will be W1, W2 point load will be acting at that overhanging, that is in opposite in a downward direction, and net soil pressure is going to act in upward direction. So by drawing this free body diagram, we are going to solve this problem as a overhanging beam. So this is the bending moment profile, and this is the shear force diagram. Here this is the sagging moment, WA square by 2, and here, this one is the sagging moment, sorry, WA square by 2. This is the hugging moment at the midspan of the foundation. So hugging moment means we are going to calculate the AST and place that AST at the top layer of the foundation. Here this is a sagging moment, so we are going to place the reinforcement at the bottom layer of the foundation. Here it is a shear force profile. So this shear force profile we are going to use in checking for one-way shear. So this is how we are going to calculate the shear force and bending moment diagram. Thank you. Next class we are going to discuss about reinforcement, how we can calculate the reinforcement details, and how we are going to check for the one-way shear and two-way shear, how we are going to design for reinforcement in transverse direction. Here we are going to design the reinforcement both in longitudinal direction and the transverse direction also. So we are going to use this bending moment diagram for calculating the longitudinal reinforcement, and to calculate the transverse reinforcement, we are going to use the bending profile in this direction. So that we are going to discuss in next class. Thank you, students.